Hello everyone, welcome to my channel Overall Good at Educating. Today we are going to learn the second chapter, that is from class 10th, the second chapter from chemistry, acid, bases and salts. Before starting the lesson, let us know what are elements and how it is divided into. Elements are the purest substances. Elements combine to form numerous compounds on basis of their chemical properties. Compounds can be classified into three categories, that is acid, bases and salts, which we are going to learn in this chapter. So acid and bases, how we can indicate them, that these are acids and those are base. So to know that it is an acid or a base, we have an substances which we call them as an indicators. An indicator tells us whether a substance is acidic or basic in nature by change in color. So we let us know some common indicators, and we have two types here: common indicators and olfactory indicators. Common indicator means from which we will get to know that an acid turns blue litmus to red litmus and base turns from red to blue. We have next methyl orange indicators, gives a red color in acidic solution and gives a yellow color in base solution. Phenolphthalein is a colorless in an acid solution and gives a pink color in basic solutions. So these are the common indicators. Second, we have common indicators are litmus paper, methyl orange and phenolphthalein. Olfactory indicators, those substances whose odor changes in acidic or basic media are called olfactory indicators. Example, we have onion, vanilla and clove oil. On adding sodium hydroxide solutions to a cloth strip treated with onion, the smell of onion is not dedicated. An acidic solution does not eliminate the smell of the onion. So these are some examples of olfactory indicators, like we have onion, vanilla and clove oil. From all these three, we can get to know whether it is an acidic or it is a basic. Hope you guys have understood about the common indicators and olfactory indicators. Next, we have the reactions of metal carbonates and bicarbonates with acid. Acid reacts with metal carbonates or bicarbonates to form salt and water with the evolution of carbon dioxide gas. What is happening here? See, we have to take one acid. Which is the acid we are taking first here? Hydrochloric acid. What it is doing? It is reacting with the sodium carbonate to form sodium chloride and water with the release of the carbon dioxide gas. Here acid is hydrochloric acid, metal carbonate is sodium carbonate. What it is give rise to? It gave rise to a salt. Salt here is sodium chloride. And which gas is liberated? Carbon dioxide gas is liberated along with the water. So next, similarly we have second example, sodium bicarbonate. So bicarbonate is NaHCO3 is reacting with the HCl. HCl is an hydrochloric acid to form a salt. Salt plus carbon dioxide. Salt we are getting here is sodium chloride with the liberation of the water. Along with that, even the water is also repeated. This is about the metal carbonates and bicarbonates with acids. Next, we have neutralization. Neutralization is very important. It is a reaction between an acid and a base to form salt and water. To form is called as what? Neutralization reaction. So here example, hydrochloric acids react with sodium hydroxide to form sodium chloride and water. That is HCl plus NaOH gave rise to NaCl and H2O. It is very important. The reason here is because we have both acid and base together to form the salt and water. HCl is acid, NaOH is base, whereas NaCl is salt and H2O is water. This is about the neutralization reaction. Next, we have reaction of metallic oxide with acids. Acids react with metallic oxides to form salt and water. Example here is copper oxide, a black metal oxide which reacts with dilute hydrochloric acid to form blue-green colored copper chloride solution. CuO. CuO is copper oxide. It is mixing with what? It is mixing with the HCl. HCl is nothing but the hydrochloric acid to form copper chloride CuCl2 with the liberation of the water. Along with that, what we are getting? Water. This is the reaction of metallic oxide with acid. Here metallic oxide is copper oxide and acid we are getting here is HCl, and what we are getting is salt is CuCl2 is copper chloride, and with the liberation of water along with it. You may get the application level question here, like which is the black metal we are using. Black metal oxide here is copper oxide, and which is the blue green colored oxide is our solution we are getting here is copper chloride solution. Next we have reaction of non-metallic oxides with base. Bases react with non-metallic oxides to form salt and water. Example, base here is calcium hydroxide. It is reacting with non-metallic oxides, which is that carbon dioxide, to form calcium carbonate, salt and water. CaOH is nothing but calcium. CaOH taken twice we are taking as calcium hydroxide, and CO2 is what? Non-metallic oxide, that is carbon dioxide, and it is forming a salt. Salt name is calcium carbonate, and with the liberation of the water, along with that even water is also formed. Okay, this is about the reaction of non-metallic oxides with base. Next, let us learn the acids and bases in water. First, acids. An acid is a substance which dissociates or ionizes when dissolved in water to release hydrogen ions. Example, an aqueous solution of hydrochloric acid dissociates to form hydrogen ions. Since hydrogen ions do not exist as H plus in solution, they combine with polar water molecules to form hydronium ions, that is H3O plus. HCl, when it is dissociates, it forms into an H plus, HCl is giving rise to H plus Cl minus ions. Okay, then even H plus and H2O give rise to an H3O minus, that is hydronium ion. The presence of hydrogen ion H plus in hydrochloric acid solution makes it behave like an acid. Base. A base is a substance which dissolved in water to produce hydroxide ion, that is OH minus ions. Bases which are soluble in water are called alkalis. Example, sodium hydroxide dissolves in water to produce hydroxide and sodium ions, that is NaOH. NaOH is a salt, that is a base. It is a base. When it is dissociates or dissolves, it becomes Na plus plus OH minus ions, that is hydroxide and sodium ions it is formed. Okay, the presence of hydroxide ions, that is OH minus, in sodium hydroxide solution makes it behaves like a base. Okay, there in the acids H plus ions makes it as behave like an acid. Here OH ions makes it behaves like a base. Hope you guys have understood about the acid and the bases, and how we can identify whether it is an acid or a base. Next we have a pH. pH of a solution. pH of a solution is the negative logarithm to the base 10 of the hydrogen ion concentration expressed in mole per liter. See, pH is nothing but like we have a pH scale. Okay, in that we have from 0 to 14. From 0 to 6 it is acidic, and from 7 is exactly a neutral. Okay, and from 8 to 14 it is a base. Okay, or we can find them as an alkali. So you can see here pH is 7 is equals to it is neutral, less than 7 all are acidic, and pH more than 7 all are base. Okay, next, pH scale is necessary for showing a relative strength of the acid and bases and alkalis. The normal pH scale ranges from 0 to 14 as given below. You may get an MCQ question or 1 mark question from this topic. That is, what you have to remember here is below 7 all are acids, above 7 all are base. So exactly 7 is a neutral. Salts having same positive ions or same negative ions are said to belong to a family of salt. So let us learn the pH of salts. Salts of strong acid and strong base are neutral with a pH value of 7. Example, we have NaCl and Na2SO4, that is sodium chloride and sodium sulfate. Next, salt of strong acid and weak base are acidic. Okay, with pH value is less than 7. Example, we have as ammonium chloride solution has pH value of 6. So salt of weak acid and strong base, that is weak acid and strong base, are basic with pH value more than 7. Example, we have a sodium carbonate solution has pH value of 9. Hope you guys have understood. That is, both strong acid and strong base are neutral. Strong acid, weak base are acidic. Weak acid and strong base are basic. Okay, and those examples also I have explained here. Next topic we have is common salt. Common salt is also called as sodium chloride. Its chemical name is called as sodium chloride. Commonly we call it as a salt. Common salt is a neutral salt and can be prepared in the laboratory by the reaction of sodium hydroxide and hydrochloric acid. Sodium hydroxide is NaOH. HCl is a hydrochloric acid. It is giving rise to what? NaCl with the water. NaCl is a salt. Okay, common salt. It is an important raw material for product of daily use such as NaOH, baking soda, washing soda and bleaching powder. Let us learn some of the in details about the baking soda, washing soda and bleaching powder. First of all, let us learn about the sodium hydroxide. Sodium hydroxide is produced by the electrolysis of an aqueous solutions of sodium chloride. It is also called as brine. Okay. The process is called the chloroalkali process because of the product form, that is chloro for chlorine and alkali for sodium hydroxide. See, in the exam they may ask about, write about the chloroalkali process, or one more question you may get about is a brine. See here, NaCl. NaCl is a sodium chloride, and what we are doing, we are mixing with the water. And when we pass the electricity to it, what happens? Sodium ions will go and attach with the hydroxide ions and form the NaOH, that is sodium hydroxide, with the liberation of the hydrogen gas as well as the chlorine gas. Okay. Here both the gases are getting liberated, that is hydrogen gas as well as the chlorine gas. Now let us learn about the bleaching powder. Bleaching powder is manufactured from chlorine gas. From where we are preparing this bleaching powder? We are manufacturing from the chlorine gas. It is produced by the action of chlorine on dry slaked lime, that is CaOH. CaOH plus chlorine gas, we are getting a CaOCl2. CaOCl2 is nothing but the bleaching powder. Bleaching powder is also called as calcium oxychloride plus water. So once more I'll tell you, see, bleaching powder is manufactured from chlorine gas, from where we are preparing this or manufacturing with the help of a chlorine gas. Okay, for what we are adding? We are adding the chlorine to the dry slacked lime, that is CaOH. So slacked lime is also called as calcium hydroxide. Calcium hydroxide plus chlorine gas give rise to calcium oxychloride. Calcium oxychloride is also called as bleaching powder. Okay, where we are using it? We are using it for the bleaching of cotton and linen in the textile industries, and for bleaching wool pulp in the paper industries. Okay, so only the paper, after the days passes, what happens to the paper? The paper will turn yellow color due to the presence of the chlorine gas in that. Okay, next, use of disinfectant drinking water to make it free from germs. Usually we have seen we get a chlorinated water. Chlorinated water is nothing but the water which is free of germs, because chlorine, once added to the water, it will destroy or kill all the germs present in the water. Next we have is baking soda. Chemical formula for baking soda is NaHCO3. It is produced on a large scale by treating cold and concentrated solutions of sodium chloride, that is brine, with ammonia and carbon dioxide. Here what we are doing, we are using the sodium chloride, that is NaCl, plus water plus carbon dioxide plus ammonia to get the ammonium chloride along with the sodium hydrogen carbonate. Sodium hydrogen carbonate is also called as baking soda. Okay, so I'll repeat it again. How we are preparing it? We are preparing in a large scale. How means by using the cold and concentrated solution of sodium chloride. Concentrated of solution of a sodium chloride is also called as brine. Brine is, we have learned already in the previous topics. Okay, and we are mixing with the ammonia and carbon dioxide. Here we are using sodium chloride, water, carbon dioxide, ammonia to form the ammonium chloride plus sodium hydrogen carbonate, that is baking soda. Okay, on heating it decomposes to give sodium carbonate with the evolution of a carbon dioxide gas. Again what we are doing, we are using here a decomposition reaction. I think you guys have remember the first chapter, that is we have four types of reactions, chemical reactions. One is combination, decomposition, displacement and double displacement. Here, sodium hydrogen carbonate, that is baking soda, is decomposing on heating and giving rise to sodium carbonate with the water and with the liberation of a carbon dioxide. Okay, so I'll repeat it again. On heating, again what we are doing, we are taking that sodium hydrogen carbonate and we are decomposing it to give sodium carbonate with the evolution of a carbon dioxide gas. Okay, you have to remember that during this carbon dioxide gas is liberated. Okay, next, uses where we are using this baking soda. Baking soda I use an antacids to treat acidity of the stomach. You think you have heard about this eno and all, right? So in that we are using this. Okay, used to make baking powder, which is used in the preparation of cakes and breads. You have seen a small amount of the flour has been prepared in the bakeries, but once it is prepared, okay, the cakes or the bread, it becomes huge. Okay, the size of that increases because we are adding the baking soda in that. Okay, and even used in soda acid free extinguisher. In the extinguishers also we are using this baking soda. Okay, even we are using at home also to prepare the idli and the dosa batter. Okay, so this is about the bleaching powder and the baking soda. The next topic we have is the washing soda. So let us learn about washing soda. Washing soda chemical formula is Na2CO3 10H2O. How we can prepare this? Once the sodium hydrogen carbonate on heating, it decomposes to give sodium carbonate with the release of the hydrogen gas. Again what we are doing is we are taking the sodium carbonate and what we are doing, we are mixing it with the, or we are recrystallization of the sodium carbonate produces washing soda. So what we are doing, again we are mixing with the water, that is 10H2O. It is giving rise to Na2CO3 10H2O. In this way we can prepare the washing soda. So I think you got to know that chemical formula of the washing soda is Na2CO3 10H2O. Now I'll repeat it again. Sodium hydrogen carbonate, that is, it is unheated, it decomposes to give sodium carbonate with the release of hydrogen gas. Again what we are doing, recrystallization we are doing. Recrystallization of sodium carbonate produces washing soda. Okay, where we are using it, I think everyone know about washing soda. Used in glass, soap and paper industries. Employed in the manufacture of sodium carbonate compounds such as borax. Okay, next we have water of crystallization. What is this water of crystallization? Water molecules which forms a part of the structure of a crystals are called water of crystallization. Means the water molecules which will take part, which forms a part of the structure of any of the crystals. Okay, those are called as water of crystallization. The salts which contains water of crystallizations are called hydrated salts. Every hydrated salt has a fixed number of molecules of crystallizations as one formula unit. Example I'll tell you: CuSO4 5H2O, Na2CO3 10H2O, CaSO4 5H2O, and FeSO4 7H2O. What you can understand from this is copper sulfate crystals, that is CuSO4 5H2O, are blue in color, and on heating strongly they lose all the water of crystallization and form anhydrous copper sulfate, which is white. On adding water to the anhydrous copper sulfate, it gets hydrated and turns blue. So this is how the water of crystallizations is. CuSO4 5H2O on heating, it gives rise to CuSO4 plus 5H2O. And again what we are doing, we are mixing with the water. Same water what we are taking out, we are again adding with the water, and again it is giving rise to CuSO4 plus 5H2O. That is together again it forms color. Once it is changed after decomposition, again the color comes back again when we are adding the same amount of water to it. The last part of the lesson is plaster of Paris, POP. Plaster of Paris is prepared on heating gypsum at 373 Kelvin. On heating, it loses water molecules and becomes calcium sulfate hemihydrate, that is CaSO4 half H2O, which is also called as plaster of Paris. Plaster of Paris is also called as POP. See, we have an equation here. What we are doing, gypsum. We are taking the gypsum and we are heating it at the temperature of 373 Kelvin. On heating, what will happen? it will loses all the water molecules and it becomes a calcium sulfate hemihydrate, that is CaSO4 2H2O on heating give rise to CaSO4 half H2O plus half H2O, that is hemihydrate it gives rise to. Okay, and where we are using this, we are using it in the hospitals as plaster for supporting fractured bones in the right position, used in fireproofing material. So you know that in the doctors, the hospitals we are using it. You know that if any bone fractures or anything happens, what we do, we the doctor recommend to give the plaster for the, so that POP should be added, so that the bone whatever it has moved, it comes back to the place. Okay, and we are using in the fireproof material, proofing material, where we are using in the fireproofing material. Okay, this is the end of the chapter. So if you have any doubts, put a question in the comment section, so that we would explain you in the better way. Thank you everyone. Don't forget to subscribe my channel, so that you will get a better videos again.